Hello, precalculus class. In this lesson, we'll continue to solve systems of equations, but this time we're going to focus in on systems of three equations containing three variables. Notice, though, all variables are first degree, which definitely makes this easier. So they're still a linear system. So the thing I want you to think about, though, is any three variable system is really an equation like this represents a plane in two directions. So if you have three variable equations, you can have a number of different situations. So remember the idea of a consistent system and an independent system or a dependent system. The first situation of three variable equations is if the planes all intersect in a single point. That means they are consistent because there's a solution and there's only one solution. So this is a consistent independent system. Well, we can also have the situation where we have an infinite number of solutions. This can be where you have a consistent dependent system right here where they're all the same plane, or you can have a consistent independent system but they intersect in a line as opposed to in a single point. So that is a situation where it's consistent and it's independent, but it's still an infinite number of solutions. And then the last situation is if you take those three planes and they're parallel, you have no solution, no points in common, or if they intersect in such a way where two of them intersect, or two of them intersect, or two of them intersect, and they never intersect all in one place or in one infinite set of places. So when they don't intersect, you can't find one set of values that satisfy all three equations, and that is an inconsistent system with no solutions. So now we're going to focus on solving systems like this. So here is three different systems of three variable equations, and what I'm going to do here is I will go ahead and solve the first one, and then we will solve the second one, and then the third one. Note, this note down here is really important, and this is how to look for the situation when there's no solution or infinite solution. So we'll keep that in mind as we go through each example. I'm going to pause the video and work out the work, and then we can discuss it. Okay, so this is a consistent, independent system of three equations with three variables, and I solved it using elimination. The first thing I did was look at the three equations and look for a place where I could quickly eliminate a variable when I grouped the equations 2 and 2. So I noticed here the y's. I could quickly eliminate these two when I add them together, and if I multiply the top equation by -2, then the first two equations could eliminate the y. So that's what I did. I started with the first two equations, took the first one multiplied by -2, and then added it to the second equation, and what I did was eliminate the y. And I have a new equation with two variables. Just hold on to that for a minute. And then I took the second two equations, and I could have grouped the first and the third, the second and third, as long as it was always two different groupings. So with the second and third equation, when you add them together, the y's cancel, and I'm left with an xz equation. Now I have to combine this one with the one I got before. So what I did was I took this one here and multiplied it by 4. So times 4 times 4 times 4. Rewrote this one down here, and then you can see that the z's eliminate. I end up with -15x equals -30. Pretty nice. X is 2. Once I have one variable, I just pick one of my two equations here to plug in x of 2, and you end up with -4 plus z equals -3, so z is 1. Now I can take these two and put it in any one of the original three equations. I chose the third one for some reason. So I have 2 minus 2y plus 3 times 1 is 3. So 5 minus 2y is 7. -2y is 2. And y is -1. And there is my solution to the first system of equations. I should check my work, though, and plug in this solution into the first equation. So 4 minus 1 is 3, plus 1 is 4, and negative 6 minus 2 is negative 8, minus 2 is negative 10. Yep, and I know I did it right. Okay, so I am now going to erase this information and we'll do the second problem. Okay, so for the second system of equations, notice all these z's. So what I'm going to do is combine the first two, and then combine the second two, and eliminate the z each time. I'm going to go ahead and pause the video and do that. All right, so I took the first two equations right here, and I could just add them together, and you get x minus y equals 5. And then I took the second two equations, I rewrote them over here. When I add them together, the z's eliminate right here, and you end up with 2x minus 2y equals 6. So now I need to combine this equation with this equation. So what I did was took this one and multiplied it by 2, and I wrote that down here. So now I'm going to, I can either add or subtract them. Let's change the sign here. So minus, plus, minus, and we'll add them together. So that cancels. Oh no, that cancels. So I end up with 0 equals negative 4. Well, that is telling me something. All the variables canceled, and I end up with an illogical situation. 0 can never equal negative 4. So what this is telling me is that I have no solution. And that means these must be an inconsistent system. So even if I had done it another way, I would have gotten to the same situation. So if we tried to graph these planes or something like that, we'd end up with either all three are parallel planes, or we have that situation where the two planes intersect and the two planes intersect, but they don't all three intersect. Okay, we have one problem left. I'm going to pause the video and clear everything, and then we'll start on the third. Okay, for this third problem, you can see once again, I am going to look at the place where I can easily eliminate some variables. And if I deal with the y, I'll be able to combine the first two and eliminate the y, combine the second two and eliminate the y. I'm just going to do this right here. So if I add the first two equations together, we end up with 3x plus 3z equals 3. And if because the y's eliminate, and if I add the second two together, I end up with 6x, the y's eliminate, plus 6z equals 6. Now, right here, I hope you notice that if I tried to do elimination on these two equations here with two variables, that this one times 2 is that one. So we already are at a situation where one is the multiple of another. So this means we have an identity, and that means we have a consistent system with infinite solutions. So these are the situation where we have a line in common, or where they're all the same plane. Actually, we can tell that they're not all the same plane because they would all be multiples of each other. So this is the situation where we have a line in common. So what we have to do is actually answer the question and say this is the solution for x, y, and z. And it is such that we can write x in terms of z. Let's see, if I wanted to solve x in terms of z, we end up with x plus z equals 1. Divide everything by 3. So x equals 1 minus z. And then we have to do the same thing and solve y in terms of z. And I can do that by taking one of the three equations originally. So I think I'll take the first one and plugging in my x in terms of z. So I'm going to replace this first x with 1 minus z plus y plus 2z equals 1. So let's see what we end up with. The ones cancel, and we have y plus z equals 0. So y equals negative z. I'm sorry, I ran out of space there. So then we have y equals negative z. And that is how you write your solution. So you really can't identify what each value is for x, y, and z, but you can write two of the variables in terms of the third. And so that is your solution that represents an infinite set of solutions. So this is a great application problem using a three-variable system. We are asked to find the numbers a, b, and c that create a quadratic function or a parabola that contains these 3 points. Note these 3 points represent x1, y1, x2, y2, and x3, y3, or all 3 points that should satisfy the equation when we are done. So the best thing to do with this problem, well, why don't I pause it? I'll write you think about it a little bit. I'll write out the answer, and then we'll talk about it. There's a lot going on here, but what I did was took this equation here, and I plugged in each of these ordered pairs one at a time. So I took the equation, and y is negative 4 equals negative 1 squared, which is 1a, plus b times x, or negative 1, so negative b, plus c. Then we do the same thing with the next point, 1, 6. So 6 equals a times 1 squared plus b times 1 plus c. And then the last one, 0 equals a times 3 squared plus b times 3 plus c. So we have a system of equations, 3 variables, 3 equations. So I combined the first two, and I just went ahead and quickly added them together. So negative 4 plus 6 is 2, plus 2a, the b is eliminated, plus 2c. And I noticed these coefficients of 2, so I divided by 2 and got this. And then I took the second two equations, but that wasn't as quick. I actually took and wanted to eliminate the b, so I multiplied the second equation here times negative 3. So 6 times negative 3 is negative 18, minus 3a minus 3b minus 3c. And now I was able to add it to the third equation, which I just rewrote. When you add them together, you get negative 18. Negative 3 plus 6 plus 9 is 6a. The b is eliminated, and then minus 3c plus c is minus 2c. I noticed they all have a factor of 2 in there, so I divided by 2, and you get negative 9 equals 3a minus c. And then I had to combine these two. So what I was able to do there was I just added them together, and I did that right here. So 1 minus 9 is negative 8. A plus 3a is 4a. The c is eliminated. Divide by 4, you get a is negative 2. Then I use this. If a is negative 2, I plugged it in to solve for c. C is 3. And then I took both of these, and let's see, I took this equation here. I thought it was the quickest. 6 is a, which is negative 2, plus b plus c, which is 3. So 6 is 1 plus b, or b is 5. Once I had those 3 variables, I can write my equation. Y equals a, which is negative 2, x squared, plus b, which is 5, x, plus c, which is 3. And that is the curve that fits those 3 points. So that's kind of a fun process to know now. So anytime you've got 3 points and you want to put a parabola through it, you can do so. Here is our last application problem we're going to do. So take a moment, read through it, and the first thing we want to do is assign variables and write 3 equations. All right, so the first thing we had to do is assign some variables. And Kelly has a whole bunch of money to invest, and she's using 3 different investment options. The first was treasury bills, which yield 5%. So I made that X be the money she invests in treasury bills at 5%. The second was her Y variable is going to be the money in treasury bonds at 7%. And our third variable is the amount in corporate bonds at 10%. So I have to use that information to write a systems of equations. The first thing is the 3 amounts have to add up to $20,000. The next thing is the simple interest on those. For 1 year, she wants to earn $13.90 per year in income. So remember that interest equals principal times rate times time. If time is 1 year, we just have to do the principal times the rate. So the principal's unknown, x, and the rate is 5%. Y, principal unknown, and the rate is 7%. And z, the principal's unknown, the amount is unknown, the rate is 10%, and that has to add up to $13.90 each year. And then the last thing, we just have a relationship between two of the variables. She wants her investment in treasury bills, X, to be $3,000 more than the investment in corporate bonds. So whatever corporate bonds is, she wants to invest more, $3,000 more in her treasury bills. Using that system of equations, I would use a substitution step first. Take and plug in X in both of these with the 3,000 plus Z. That way you're down to two equations in terms of Y and Z, and then you can use elimination on them. I'm going to pause it here and let you finish the problem, and then I will give you the answer. And there's your answer. It turns out that she's going to invest $8,000 in treasury bills, $7,000 in treasury bonds, and $5,000 in corporate bonds. Now, if you asked me, I would invest it all in corporate bonds at 10% return and get the most for my money, but maybe there is different limits and different risk reward situations there, so that's why you have a diversified portfolio. So that question is going to be a lot like some you're going to see in the textbook homework. Good luck on the homework, and we will start matrices with the next lesson.